Okay, Assalamualaikum. Today I am going to talk about the introduction of magnetic levitation. So technically, magnetic levitation has come to be used in a wide variety of different contexts, ranging from suspending a small laboratory scale stationary object so that it is isolated from vibration of its surrounding. As an example, magnetic levitation is we have maglev trains, which is which is using magnetic levitation to float above a track without making contact with it. So we basically can say that magnetic levitation works by using the principle that like magnetic poles repels each other, and and opposite magnetic poles attract each other. In maglev trains, two sets of magnetins two sets of magnets are being used. The first one is repel. One set of magnets repels and push the train up of the track, whilst the other set magnets moves the train ahead at high speeds. Maglev trains are more efficient than conventional trains because they don't lose energy to the friction trails from the rails. They can also travel faster than the normal traditional trains and produce less noise and provide smoother ride. And for the most important thing is, it is eco-friendly. Have you ever wondered what is the relevance of electricity and magnetism concept in our daily life? First and foremost, electric. People are using electricity for lighting, heating, cooling, and refrigeration, and for operating appliances like computers, headphones, and any other electronics gadget. Machinery and public transportation is also use are also using electricity as the source of power. On the other hand, magnets play a vital role in modern life, appearing in countless everyday items and technologies, from the simple fridge magnets that hold up photos to the powerful magnets inside the medical imaging machine. And their uses are diverse and indispensable. Let's explore where magnets are found and how they impact our daily life. Furthermore, electricity and magnetism are important concepts because they are fundamental to the working of many things in our daily life, including technology, chemistry, and protection, air travel, and of course, the interaction between electricity and magnetism is called electromagnetism. Flowing electrons produce a magnetic field, and spinning magnets cause an electric current flow.
Let's take a closer look at maglev trains, one of the most fascinating and well-known uses of magnetic leverage. Let's delve deeper into one of the most exciting and widely known application of magnetic levitation, maglev technology, maglev, which is maglev trains. Okay, so I will describe about the maglev train. Maglev train don't make physical touch with the ground since they float above a track using magnetic force. Because of this, they do not encounter unusual friction between wheels and track, which leads to first, increased velocity. Second, reduced deterioration. Last, more comfortable. Okay, next. Maglev technology is based on two fundamental magnetic concepts, which is the train is rise above the track using electromagnets in the electromagnetic suspension (EMS) system, which continuously modifies magnetic force to maintain the train stability. Okay. Next, we have electrodynamic suspension (EDS). This technique will allow for levitation and propulsion by using superconducting magnets to generate magnetic field that push the train upward. Okay.
Assalamualaikum. So I'm gonna talk about example of real world implementation of magnetic levitation. For the first one, such as maglev trains. Um, in Shanghai maglev in China, fastest commercial train can go for 431 km per hour. Other than that, Chuo Shinkansen in Japan, under construction will reach speed of 500 km per hour. And as one, Transrapid in Germany, a tested system for high-speed travel. Secondly, for medical application, blood pump use magnetic levitation to prevent mechanical wear. Other than that, MRI machines use powerful magnetic field for imaging. Last but not least, for manufacturing, magnetic bearings used in high-speed machines to reduce friction. And last one, flywheels in energy storage system to minimize wear and tear.
Hi, Assalamualaikum warahmatullahi wabarakatuh. And my name is Muhammad Adam Haris bin Muhammad Sharizad, 2023-891688. So today I'm going to explain about the potential benefits of the maglev train. The first thing, it is high speed. It has a very high speed compared to the conventional train, and it will save us more time. So for example, the French TGV LGV EST holds a record speed of 574.8 km per hour, while the LO series maglev has a breaking record speed which is at 603 km per hour. For your information, the French TGV LGV established hold is a company that produce conventional train. And then the next one is about the maintenance and efficiency. For the first bullet, the maglev trains float above the train tracks using magnetic levitation, eliminating physical contact between the vehicle and the guideway, thus preventing it from wear and tear on the wheels and the track. This is because the magnetic levitation train doesn't use any any wheels. It just float on the track. So the next bullet is its moving mechanical parts are replaceable and renewable with durable electronic and electromagnetic components. So the last bullet, conventional trains can sometimes cause misalignment on the track and cause accident. But with this magnetic levitation train, we can prevent it from happen, thus making it more safe for us to use. So we have talked about the benefit. Now we are going to talk about the challenges that we need to face to build a maglev machine or a system. The first thing first, we're going to talk about its high initial cost. To build a magnetic levitation train, we need a dedicated track. We need a new track because the old one we cannot use it for the magnetic levitation train. As the example, uh, this Scotland need around £6 billion for a 80-kilometer track from Glasgow to Edinburgh. And then the next one, I'm going to talk about the competition with the existing system. As we all know, we have use the conventional train for a long time and we get used to it. For the maglev system to be used and to be accepted by the community is quite hard because it is a new system. So thus making it face competition from well-established transportation systems such as conventional trains and airplane. Convincing user to switch to a new mode of transportation can be challenging. So like I said, it is a hard challenge for magnetic levitation company to build a community that can accept them. So right now I'm going to talk about the historical development of magnetic levitation. For the early concept in the 1902 and 1907, the German engineer Alfred Zehden submitted patents for a train propelled by a linear electric motor. In the 1908, Cleveland Mayor Tom I. Johnson filed a patent for a wheelless high-speed railway levitated by an induced magnetic field. In the 1934, Kemper proposed using magnetic fields to levitate train, laying foundational concept for maglev technology. This is where the key point that this magnetic levitation concept come from. And then the next one in the late 1940s, British electrical engineer Eric Letway developed the first full-size working model of the linear induction motor, a key component in maglev system. In the 1970s, Letway discovered a new arrangement of magnet that the magnetic river, allowing a single linear motor to produce both lift and forward thrust, facilitating the development of maglev system. And the last one, in the 1984, the first commercial maglev people mover, simple called maglev, officially opened near Birmingham, England, operating at speed up to 42 km per hour. So on this slide, I'm going to talk about the current innovation of maglev train. First, high-speed prototypes. China unveiled the CR450, a maglev train prototype capable of reaching speeds up to 281 miles per hour or 450 km per hour. This train features advanced technologies such as reduced drag, vibration control, lightweight construction, and intelligent system for the real-time data monitoring. Not only that, it has also enhancing safety and performance. Passenger amenities including adaptive lighting, touchless restrooms, and a dining car with a plush business class section. So, for the next point is the sustainable design. Innovations on maglev train design focus on sustainability, including the use of lightweight material and energy-efficient propulsion systems. These advancements aim to reduce energy consumption and environmental impact, making maglev trains a more eco-friendly transportation. All of this innovation is gained by our modern technologies rather than the old school train maglev. So on this slide, we have all the not all, but some of the reference that we use to make this slide done. So we have reached our final destination, which is the end. And thank you for watching. Don't forget to like, comment, and share, guys. Sudah dapat sesuatu, sila komen.